In this lab, we'll start off with a simple topology of two routers, router 1 and router 2. What we'll do here is configure router 2 as the DHCP server, and we'll configure router 1 as the DHCP client in this topology. No configuration has been done on these routers. At the moment, as an example, on router 2, show IP interface brief shows me that all the interfaces are currently down. No IP address has been configured. So the first thing I'm going to do is go onto the fast Ethernet interface and configure an IP address of 10.1.1.2 with a /24 mask. I'll no shut that interface. And now I'll configure the router as a DHCP server. So to configure a DHCP server, the first thing you need to do is type IP DHCP. That gives you a range of options, but the one that we're looking for is pool. So pool, and then we specify a name, such as clients as an example. This is just a name to uniquely identify the pool that you're creating. And that's because you can have multiple pools configured on a router. Network, we need to specify the network that devices will be allocated addresses from. Now it's important that the IP address that DHCP requests are being received on, which in this example is fast Ethernet 00, be in the same subnet as the network. Otherwise the router is not going to allocate addresses from the pool. So this interface is configured with an IP address of 10.1.1.2, and we are configuring a network of 10.110/24. There are many options available in the pool. We've already configured the network and mask. Next option you'll probably want to configure is default gateway or default router. I'm going to set that to router 2. You would also want to specify options such as DNS server. In this example, I'll configure the router as a DNS server, but typically what you're going to want to do here is configure a real DNS server somewhere in your topology. So I'll just configure a single DNS server being the local router. You can specify how long addresses are allocated to hosts. The default is 1 day. I'm going to specify a lease time of 7 days. Now for devices such as IP phones, you can specify different DHCP option codes. 150 is TFTP, and I'm going to specify an IP address of a TFTP server. Now in a real implementation, your IP telephones will get their configuration typically from a Cisco Unified Communications Manager or from a Cisco Unified Communications Manager Express router. So this would be the IP address of the Cisco Communications Manager. In our example, once again, I'm just going to set that to the local router. Now to stop conflicts and allocation of addresses that belong to servers and routers, use the command ipdhcp excluded address, and you specify a range of addresses to exclude from allocation to devices. Now my router has an IP address of 10.1.1.2. I don't want the router to allocate its own IP address to host devices, so I'm going to set the exclusion range to include the router's IP address and some extra IP addresses here that would typically be determined by how many servers or other devices are going to have IP addresses statically configured. Show run will show me my configuration. So it's quite a simple config. I've got my exclusion range. I've created a pool called clients. Clients will be allocated addresses in this IP address subnet. Default router is router 2, the local router. DNS server is set to that, and option 150 is set to that as well. Once again, typically these would be set to servers in your live network. I've set the lease to 7 days. The default is 1 day. Show IP DHCP gives me different options, including pool. This can be useful because sometimes you can make a typing mistake and you may exclude all of your addresses. But notice here, total addresses is 254, leased addresses is 0, no addresses have been leased, address range is in this range. Let's look at bindings. Have any addresses been allocated? At the moment, no addresses have been allocated. So let's go to the client. I'm going to change the MAC address of this client to something very simple so that we can read it in the output. So MAC address is going to be ABC. IP address is going to be set to DHCP. So the PC will request an IP address from the server when I type no shut. Show debug. Let's run a debug so we can see what's happening. Debug IP DHCP server. And we have different options. I'm going to go for packet, which shows me lots of detail. So debug IP DHCP server packet. Now when I hit no shut, we should start seeing requests from the client to the DHCP server. And there we go. We've got a DHCP discover message received from the client on interface fast Ethernet 00. The DHCP server will allocate an address without class information. We didn't configure a name or a class for this device. The DHCP server is offering an address to the client, offering it this IP address, and is sending the reply to the MAC address of the PC that we configured. So that MAC address. The client then requests that IP address from the DHCP server. DHCP server sends back an acknowledgement. So show IP interface brief. Fast Ethernet 00 on router 1 has been allocated to this address through DHCP. Show IP route. The router has learnt about the gateway of last resort because we configured a default gateway or default router in the DHCP pool. So router 1 has learnt about that network, and a static default router has been added to the routing table. It's as simple as that to configure a basic DHCP server on a Cisco router and allocate addresses to client devices. In the next video, we'll look at using Wireshark to actually view the messages sent between the client and the server.